Scooby snacks?
Yes, they're Scooby snacks.
I have that for lunch.
I'm not sure if that's even pointed up at the board.
I got you.
Okay, so let's start this. When I first started teaching this class in calculus in general, so many of these questions stumped me because they require you to think so differently. So it wasn't until I had a lot of practice that now they're easy. These can be easy for you too. You just got to see a lot of them and then they get a lot easier. But what I always learned for myself is like, charge ahead. Just start doing something. Once you see max and min, you know what to start doing. Take derivatives, find critical values, set up a number line. Just start it. You know what I mean? So don't get too caught up in like, am I doing the right thing? Just do a thing, and you might be right. So when I know I have to find the min and max, I go find the derivative, and I know how to do that, so I'm happy. And when I get to the derivative of p being 0, that's cool. So I say, bless you, set this equal to 0, I did factor out a 3x. When I set it equal to 0, so I got critical values of 0 and 4. Did we get that far?
Mm-hmm.
You would have at least gotten yourself probably 2 points so far.
2 out of 9.
2 out of the 9, okay?
Nine.
Find the max and min values. So just
Been
like
there.
normal, I make a number line with 0 and 4, and I look at the derivative. So I, again, don't have to plug anything back in where p is. I just have to look at the derivative. So when x is less than 0, I got f prime was positive, I got negative, I got positive. Well, because my function, even though it has a p, p's just a constant, there's nothing weird about it. Like there's no asymptotes or anything weird. There's no denominator. I know that since this goes from increasing to decreasing, I know that this is a max. And decreasing to increasing, I know that this is a min. There's probably another point for you in identifying the maxes and the mins. Is that okay? So now here's where it gets a little bit tricky, but not that bad. If they want to know where's the max, well, the max happens at 0, p, when I plug that in. And the min happens at 4, negative 32 plus p. So that whole thing's probably a good 4 points or so. That's good.
Yeah.
And we didn't do it. Okay. This is a favorite question of theirs, asking about roots.
Good.
Well, remember that question when we were studying for the last test that said, for what values of k does that particular graph have 2 roots or 2 solutions with the line like y equals 1/2? And you had to know that k had to be smaller than 1/2 or whatever it was. Or y equals 1, and so the answer was k could be 1/2, and then we knew that it came down below. Do you know that question, kind of? This is really similar to that question when they're asking about roots. So it says, for what values of p does that graph have 3 distinct real roots? Well, what does a root mean?
Y equals 0.
Y equals 0. When does it cross the x-axis? When does y equal 0? Well, this is cubic, right? So I know that in general this looks like this. It's a cubic function. So typically it would cross the axis 1, 2, 3 times, and they want you to make that happen and tell you what values for p that has to happen for. Well, we know that there's a max at 0, p. So let me just put that here. Let me say this is up at p, and I have a max there. And my min is at 4, negative 32 plus p. Well, I'm going to put this down here. It's important that I put the max above the x-axis and the min below the x-axis so that when I connect them, I get those 1, 2, 3 roots. Do you know what I mean? If I thought about this as like the max here and the min here, I'm not going to get my roots. I'm only going to get 1. If I put it a max here and a min here, I'm only going to get 1 root. So to make it work so that I get 3 roots, I have to make the max be above the x-axis and the min be below. Nowhere does a book ever tell you that. That's never part of like a class. That's where like the original thought comes in. That's the hard part. To think about, if I want to get 3 roots out of that graph, my max has to be above the x-axis and my min has to be below. So, what has to be true about p? What has to be true about the max where p is concerned?
Between 0 and 32.
Oh, you're putting it all together? What did you say? Between what?
0 and 32.
Between 0 and 32. I kind of didn't think it that fast. I was like, all right, I know that p has to be bigger than 0. to get that max above the x-axis. And I know that negative 32 plus p has to be less than 0 to get the min below the x-axis. I know those two things have to happen. So p's got to be bigger than 0 and p's got to be less than 32. And there's what p has to be. P has to be between 0 and 32 to make that happen. That's not easy.
And just that part with 5 points.
No, there's a part C that we weren't ready for,
yeah.
so probably that was like 2 or 3.
Oh,
and then
that's
the
the answer?
yeah, P is
Oh, I
between
thought we
0
had to find the values. I was
yeah.
like,
One,
Oh, yeah, no. And there's
2,
another good, like,
3.
they don't always mean, right, like,
It
what
should
P
say,
has to be.
it should say the range.
If it said the range of values, we might have had an easier time, but, yeah. Okay.
Oh, wow.
Okay, these are the kind of questions you're gonna say. So, there's 2 of them.
Good work today.
There's a few more. Let's do these for homework. I gathered some multiple choice questions, so you can kind of see what the multiple choice questions are gonna look like. The multiple choice questions for this stuff are a lot easier than the open-ended. The open-ended are pretty tough.
You don't get one. Yeah, I do. So. Yeah, I'm in this class. So oh, you gonna do something?
Alright, I've got a hole puncher, or get yourself a folder. I would really start trying to keep this stuff together. This is the stuff you want to study from. The book
Years
problems
nine.
are okay, this stuff's way better.